Now we're in 6.2, so we're going to be looking at real applications of the normal distribution. So this section presents methods for working with normal distributions that are not standard. So that means that the mean is not 0, or the standard deviation is not 1, or both of those could be in play. So however, we can use a simple conversion that will allow us to standardize any normal distribution so that the same methods of the previous section can be used. So essentially, we're going to be adding a step in the process between looking at a z-score and looking at the table, or vice versa. And we've already seen the formula. It's the z-score formula. That allows us to standardize the process so that way we can use the tables, because the tables only work if it's standard. So we're essentially going to have a non-standard situation, so the mean won't be 0, but it still's in the middle. And then we're going to be looking at a specific value of x related to that information. And it's going to be either shaded to the left or to the right or in between. We'll standardize the value of x by changing it to a z-score, and then we can use the table to find the probability. So the steps are going to be to sketch this curve, obviously, again, label the mean and the specific x value or x values, and then shade the appropriate region. For each relevant x that is a boundary, we're going to use the z-score formula and change it to a z-score, and then we can use the table to find the area of the shaded region. So looking at this problem here, suppose that we have a normal distribution with a mean of 30 and a standard deviation of 5. Find the probability of getting less than 36. So our initial drawing should look something like this. We got 30 in the middle, and we got x is equal to 36. And because it's less than, I didn't do it on the graph here, but we would shade this side. So all of this would get shaded because that's less than 36. So next we would standardize it. So we plug it into the z-score formula. So x is always first, so 36 minus the mean divided by the standard deviation would give you 1.2. Now we have this. So now the mean is 0 and our z-score is 1.2, so it's got to be on the right-hand side, and we're still shading to the left. So when we go to our table and look up 1.2, we're going to get 0.8849. And because it's shaded to the left, you're done. So that's your answer. So it's really a lot of the same thing, but it's just got that extra step where we have to use the z-score formula. So let's try it out. So we got find the area of the shaded region. So remember, areas and probabilities are synonymous if they're standardized. So if the graph depicts IQ scores of adults, and those scores are normally distributed with a mean of 100 and a standard deviation of 15. So I always like to just kind of write it using the notation. So mu is equal to 100 and sigma is equal to 15. So this, though, is going to be our value of x. X is 120. So if we have x is equal to 120, the first thing we got to do is plug it into our z-score formula. So we got 120 minus 100 divided by 15. So if you use your calculator, be careful. Don't do it in one step. If I type 120 minus 100 divided by 15 all in one step, it's going to give me this, which is wrong. It's not 113.3. You have to do it in two steps. So 120 minus 100 equals, then we divide that by the 15, and you get 1.33333. Now, because it's a z-score, remember they round to two places. And so now we can use our table and find that z-score. So 1.33 is 0.9082. So this would tell me I have an area equal to 0.9082. And because it's shaded to the left, I'm done. So now the same thing goes for this one. So we got two values of x we got to look at. So if we look at x equal to, let's do the 115 first. So we'll get 115 minus 100 over 15. We're using the same mean and standard deviation. So if we do this one, 115 minus 100 is 15, divided by 15 is 1. So you get 1.0 for that one, which if we go to our table, 1.0 and then 0, so 0.8413. All right, so let's do the 90. So the 90 minus 100 over 15, and just to be safe, let's do that one on the calculator. 90 minus 100 equals negative 10, divided by 15 equals negative 0.66666. So let's round that two places, so negative 0.67. And so now if we go to our table, we will find an area equal to, so we're going to go to the negatives, negative 0.672514. And then what's the last step? What do we do with those two values, those two areas? Remember, we got to subtract. So 0.8413 minus 0.2514, slide it over a little bit, which equals 0.8413 minus 0.2514, 5899. So really not terrible, right? Okay, let's do these last two real quick, and then we'll switch it up. All right, so now they're not giving you much for drawings. So we have weekly salaries that are normally distributed with a mean of 290 and a standard deviation of 45. They're always going to have to give you that kind of information to start. So again, it doesn't hurt just to use the right notation, so that way you have it right in your formulas. So mu is equal to 290, sigma is equal to 45. So find the probability that randomly selected adult has a weekly salary that is less than $345. So now if we draw our bell, the mean's got to be in the middle. So 290's got to be here. 345, that's going to be our value of x. So that is going to be over on the right-hand side of 290 somewhere. And now we got to decide which side to shade. So it's less. So we got to shade on this side. All right. So now we got our picture. So now our next step is we got to change this x into a z. So x minus the mean divided by the standard deviation. So let's see what we got. 345 minus 290 equals that, divided by 45, 1.222222. So again, we're going to want to round it properly to 2 decimal places. And now we can go to our table. So the probability should equal 1.2 and 2. So 8888. And that one's done because it's shaded to the left. And based on our picture, we can see that it has to be more than half of the bell. So 0.8888 is probably correct. It's got to be correct. We're perfect, right? So find the probability that a randomly selected adult has a weekly salary greater than 370. So now let's get our picture again. So we got 290 in the middle. 370 is going to be over here on the right. And that's our value of x. Now that we want to shade on the right. So looking at this picture, we can see our answer is going to be pretty small. At least it should be. So now we got to do our change. First change to a z. So let's see what we get. 370 minus 290 is that, divided by 45. 1.77777. So the second 7 is going to have to round to an 8. So this is 1.78. Okay, so now we got z is equal to 1.78, which says we have a probability equal to 1.78. 9625. So is that my answer? You better be saying no. You better be screaming no. Remember, we said it's really small. So if we had 96% of the bell shaded, then that would make sense. So your answer, you have to subtract it from 1. So 0.0375 should be your answer for that. Okay, so let's stop there, and then the next part will be switching it up. See you in the next video.